Okay, so we're going to start by looking at the tangent function today. The formula for tangent is y equals a tangent of bx minus c plus d. Very, very similar to the sine function. D will control the middle line, moving it up or down from 0. A doesn't exactly control the amplitude. If you look here, when A is 1, this point on the tangent graph corresponds with 45, or halfway between 0 and 90 degrees. So it's at the quarter point of the graph. As A changes, it'll stretch this up. So if A were a 5 value, it would stretch this point up 5 units. So we'll use A in a very similar method to amplitude, but technically tangent has no amplitude because it has no maximum or minimum value. These endpoints go at the asymptotes off to negative infinity and positive infinity, respectively. The other difference, we still set bx minus c equal to the beginning and the end of the period, but tangent has a different period than sine and cosine. The beginning period of tangent begins at negative 90, or negative pi over 2, and the period ends for tangent at 90, or pi over 2. So we set bx minus c equal to negative pi over 2, and then to positive pi over 2, because that's the period for tangent. The other thing I want you to notice is that tangent is an increasing function. That is, it starts on the left, and it's increasing as it moves towards the right-hand side. Just like sine and cosine, tangent is a period graph. So today we'll just draw one period, and you would simply repeat the pattern again and again if you wanted to draw multiple periods. So let's begin by looking at our first example here. So we have y equals negative 2 tangent of x over 2 plus pi over 3 plus 1. Just like we did for the sine graphs, we're going to start by identifying the middle and the a value. The middle number is that number back here, which is 1, and the a value is negative 2. Because it's negative, it's going to flip the graph upside down. So we just said how tangent is positive normally, increasing from left to right. Well, because it's negative now, because we're making it negative a, it's going to flip the graph, so it's actually going to be decreasing from left to right. So keep that in mind as we draw this graph. So let's begin by placing the middle line. So we're going to move up 1 unit on the x-axis, the y-axis. And let's make sure to label our point here. So let's grab our 1. And because we're going to be drawing asymptotes later, I'm going to make our center line here. It's still going to be dotted, but I'm going to choose the color green to make it different. Okay, let's mark our amplitude. So we're going to start by going down 2. That puts us down here at negative 1. And we're going to go up to 2, 3. So I'll go ahead and label that as well. Okay. So we have our y-axis completely labeled. Now we need to label our x-axis. To label our x-axis, we need to know when this period is going to begin and end. Now, normally the period for tangent begins at negative pi over 2 and ends at positive pi over 2. But because we have this complicated parenthesis value, we need to actually compute that. So normally, the period for tangent would end at negative pi over 2. So we set the parenthesis equal to negative pi over 2, and then we solve for x. And once we solve for x, that will give us our new place. And when we do solve for x, we end up getting x equals negative pi over 3. So our period is going to begin right here at the value of x equals negative pi over 3. To find out when it ends, we do the same thing, but this time we set it equal to pi over 2, where a tangent typically ends. We solve for x, and sure enough, x equals 5 pi over 3. So our graph this time is going to end over here at 5 pi over 3. And to label these on the x-axis, I'm just going to move these right here. Just like we did for sine, we need 3 points in the middle. We need the exact middle, and then we need the quarters. So something like that. I'm going to carry these lines up into our new middle line. Okay. Now, at the ends of the period for both tangent and cotangent, we'll see next, the ends of the periods are asymptotes. So I can just draw asymptote right there, asymptote right there. So we got asymptotes at the end. Okay. In the middle of tangent, the line crosses the middle. Let's mark our point right there. So there's the middle. Now normally for the middle, we'd go down to the amplitude like point, the a value. We'd go down because tangent's an increasing function, but because it's negative, instead of going down, we're actually going to go up first. So we'll draw our first point here, and then we'll draw our next point down. And again, we knew that because the a value was negative. So then to connect these points, we don't want a linear line. It's going to ride the asymptote. It's going to inflect in the middle and ride the asymptote back down. Again, your shape should be similar to the shape we saw here, where it comes in, curve follows the asymptote in, curves in and inflects, and then curves back out, except our graph we just drew would be in the negative direction. Okay, so there we have a successful completed graph of the tangent. Okay, let's look at cotangent. Cotangent, again, same basic formula, but again, two things have changed from tangent to cotangent. Cotangent, unlike tangent, is a negative graph. It starts at the asymptote from the left and decreases, inflects in the middle, and decreases as it goes to the right. The period, once again, has also changed. The period for cotangent, we have an asymptote at 0 and an asymptote at pi. So the period for cotangent would be from 0 to pi. So when we plug in our bx minus c values, we're going to have to plug in 0 and pi for cotangent. So sine and cosine, their period goes from 0 to 2 pi. Tangent, negative pi over 2 to pi over 2. And cotangent goes from 0 to pi. Those are our three periods you have to remember. So let's look at our first cotangent example. Y equals 3 cotangent of 2x. Again, first step, identify that middle value. The middle value, this time there's no number out there, so it's 0. So we keep our middle right here on the nice x-axis. Our a value is 3, so we're going to move up 3, and we're going to move down 3. So let me go ahead and put those marks on the graph. So we move up 3, 1, 2, 3, and we're going to move down 3, 1, 2, and 3. Okay, so up 3, down 3, there we go. So we have our y-axis labeled. We have our center at 0. We have up 3 and down 3 for our a value. Now we need to make our x value. So in come here, my parenthesis values. My parenthesis values are 2x. So I'm going to make 2x equal to the traditional old starting place, which is 0. So 2x equals 0. Solve for x, and guess what? We're still starting at 0. To figure out where we're ending, cotangent ends at pi. So 2x equals pi. Solve for x. X equals pi over 2. So we're going to, this graph's literally been chopped in half. We're going to end at pi over 2 instead of all the way at pi. So 0, we have that place marked right there. And then right here, we'll make that pi over 2. So let's go ahead and pull that over to mark that. Next up, we need asymptotes to indicate the ends of the period. So I always draw my asymptote a little bit longer than the x-axis so that you can tell there is an asymptote on there. And then my other asymptote's going to go at pi over 2. In the middle, I need to indicate my middle. I need to indicate my quarters. So 3 points, and that will help me graph it. I know in the very middle, that's where the cotangent graph will inflect. So I mark that point. Cotangent's a decreasing function. There's no negative sign to the a value, so it's still going to stay decreasing. So for my helper point, I go to the quarter. I'm going to go up to the a value, put my little helper point up there, and vice versa. At this quarter point, I'm going to move down to my a value. So I have my 3 points. So I'm going to come in. I'm going to ride the asymptote. I'm going to slightly curve through the middle and then come back to the asymptote. it's not easy drawing the line out here. But again, if you look back at the picture of it, you can see how it kind of curves in. Ours won't curve too much because it's being pulled and stretched almost straight, like linear like, because the a value is 3. So it's stretching this graph by a factor of 3, so it's going to be really stretched out. And it's also being squished in by half because we cut the period down to pi over 2 for this particular graph. So it's going to have a little squishy look to it. But it's much easier to draw these out with a pencil and pen rather than a finger and a mouse pad. So that is how we graph tangent and cotangent. So remember the keys. Tangent, the period goes from negative pi over 2 to pi over 2 and is an increasing graph. Cotangent goes from 0 to pi and is a decreasing graph. At the ends of the periods are asymptotes for both tangent and cotangent. At the very middle is that inflection point, and then we use the a to give us the quarter value so we can have nice little helper lines to help us graph these graphs. So that's graphing tangent and cotangent. In part 2, we will look at graphing secant and cosecant.